All right, so everybody, thank you very much for joining us for FWM203. This is the session titled, I Did Not Know AWS AppSync Could Do That. Really glad to see everybody here, because I think that if you're here, you are here because you're interested in AppSync and you want to learn more about AppSync. So the goal for this session is, I want everybody to, during the conversation that we're going to have, I want everybody to kind of get that feeling like, I didn't know that AppSync could do that. Or I did not know that AWS AppSync had the solutions for some of the challenges and problems that I am facing in my organization and in my team. So we're going to have a good time. We're going to talk about a lot of different things today. My name is Brice Pelle, and I'm a principal product manager at AWS AppSync at AWS. And I am joined by my good partner here, Michael Liendo.
Hey everybody, I'm super excited. Can I get a quick head nod on my headphones? Okay, we're good. My name is Michael Liendo, Senior Developer Advocate at AWS. I come by way of the Amplified team, and then I transitioned to the AppSync team, and then now I kind of oversee as a developer advocate for the NAMER region, so North America. We're in for a treat today. This talk title is my baby. I came up with the talk title name. Brice is just here along for the ride. No, it's gonna be a good time. If you've attended any of my sessions before, you know that demos and interactivity are really kind of my forte. We can do slides all day, but we have like 5 demos in this session showing you different use cases that AppSync can be a part of. So you're gonna take your phones out at some point, you're gonna have QR codes to scan, but it's gonna be a good time. Brice, back to you.
Awesome. That's what I said, it's gonna be a fun time. So we've got a lot of content, so let's get to it and let's get ready for some great demos. So for our agenda, we're going to look at a couple of things. We're going to talk about flexible data access with AWS, with AppSync GraphQL. We're going to talk about real-time events with AppSync Events. We're going to talk a little bit about AppSync and how you can use AppSync as an AI gateway for your generative AI backends. And then I'm going to spend a little bit of time to talk about all of the security and operational features that we provide that lets you do your job easier when it comes to handling and operating your APIs. So let's get started with GraphQL. It's specifically with AppSync GraphQL. So before I dig into it, how many people here have used GraphQL in the past? Okay, good show of hands. And out of those hands, how many people have used AppSync? Okay, maybe a bit less, but a good amount. So maybe to level set a little bit, let's start by taking a step back and talking about what GraphQL is, right? So GraphQL is a query language for your API. Essentially, it's a specification that allows you to define the capabilities and the features of your APIs. It allows you to define a fully typed document that defines the queries, mutations, and subscriptions that are available in your API. It's different from REST because with GraphQL, your clients can essentially make a single request that are then resolved by your GraphQL API, by AppSync in this case, and can interact with multiple data sources in a single request. The key thing here is that because GraphQL and your GraphQL API does a lot of the heavy lifting for you, there's less work to do at your client. Your client can ask for specific data in a specific format, and they get that data that they asked for in the shape that they requested it in. So your clients get what they want, nothing more, nothing less. So there's less work to do at your client. The other great thing that GraphQL makes available is subscriptions. Now, with subscriptions, you can implement real-time capabilities. Subscription essentially says that any connected client can receive any mutating event that occur within the API. So if I have a connected client and I want to send them real-time notifications, I can do that with GraphQL, and I can do that with AppSync. AppSync implements subscriptions using pure WebSockets. So GraphQL enhances API development, and the data shows it, right? Gartner estimates that by 2027, more than 60% of enterprises will use GraphQL in production. That is up from less than 30% in 2024. So even though GraphQL has been around for quite a bit of time, according to STIS, it's still kind of early days. We're just getting started. And we can expect enterprises to start making a lot of moves in this space and introducing GraphQL into their own production environment in the next couple of years. Now that being said, If you want to get started with GraphQL, you have a couple of options. You can self-host, you can implement your own solutions, but that's a lot of tedious work. A lot of time when we talk about hosting solutions, it's easy to get started with something that's small, but as soon as you want to launch something into production or launch something into enterprise, you've got to deal with a lot of challenges. So self-management of GraphQL, it's complex, it's costly, and it's tedious. And there's a better way. That's why we introduced AWS AppSync. And AWS AppSync allows you to deploy fully serverless, fully managed GraphQL APIs. It's 100% serverless. There's less code, which means less complexity, and it is fully secure and performant. That is our number one concerns anytime we implement features. Because AppSync is fully managed, you can get started quickly with very little code with the confidence that your API is going to be able to scale to meet your demand. And we've got a ton of customers that are using AppSync GraphQL today. These are some of our customers that are using GraphQL, and you can find their full stories if you go online and look up AWS AppSync. So, if you get started with GraphQL, you may start thinking, well, I already have REST APIs, what do I do about my REST APIs? And the reality is that I really like to think about GraphQL as an enhancer. And GraphQL allows you to enhance your REST APIs in a lot of different ways. GraphQL works great alongside REST. So you may have an application that's using REST today and you want to start introducing additional features. You can do that by introducing GraphQL right next to REST. You can use a strangler pattern to start removing some of the capabilities out of your existing REST APIs and then move them to your GraphQL APIs. These two things can coexist. You can use GraphQL on top of REST APIs. So this is a very common pattern, backend for frontend, where you introduce AppSync to serve as the BFF for your application. And you can start implementing specific user experiences in your AWS AppSync GraphQL API specific to your client. This allows you to stay really specific in your GraphQL API and to let your REST APIs be generic, simple, and serve a purpose for multiple applications. And then finally, GraphQL works great in real time with APIs, with REST APIs. So when I talk about real time, a lot of time customers that are using REST APIs implement polling to get real-time notifications out of their REST APIs. No, don't do that. There's a better way. You can simply use AppSync, leverage some AppSync subscriptions to forward real-time notifications to your API. This is done over WebSockets. So when you implement this with AppSync, there is no more polling. You can start removing pressure off of your existing REST APIs and allow AppSync to provide a more efficient implementation with less latency. This is a great solution for your APIs as well. If we take a closer look at the BFF pattern, so I talked a little bit about that, so I'm not going to spend too much time on this side, but BFFs is something that we see a lot of customers adopting for a couple of reasons. This is great for the front end because front end teams can take full ownership of their BFF deployment. BFF deployments are tightly coupled to the specific user experience that you're trying to implement at your application. So instead of dealing with generic APIs and trying to figure out how to interact with an API, you can simply have something that's custom-made, tailor-made, bespoke for your front-end application, and you can move at your own velocity. Meanwhile, for the REST APIs, this allows them to stay generic, to stay simple, and to have a clear focus and evolve independently as well. We see a lot of our customers implementing BFF. If you take a simple example here, I'm going to walk through this example quickly. Let's say you have a requirement and you're trying to implement a weather API for your new application. You want to use the API provided by api.weather.gov. Your requirement is that you need to retrieve weather information, you need to retrieve location information, general forecast, and hourly forecast. If you use the api.weather.gov API, this is not something that you can do in a single request. So you can implement a BFF to do this in a single request for your application. The way you do this is by starting to create a schema for your API. I create a query with getWeather. My getWeather takes in two arguments, to coordinate X and coordinate Y, and returns a point. My point has a bunch of fields, including a forecast and an hourly field. These are fields that need to be resolved. I need to link a data source to these fields. The second thing I'm going to do is simply create my data source that points to the REST API. And as you can see here, it's really simple. I go into the console, I define my HTTP endpoint. Now this data source is reusable by any resolver in my API. I then implement my resolver for get weather. Again, it's very simple. In my request handler, I simply say, I want to send a get request to this resource path. And you can see that I'm using the coordinate X and coordinate Y arguments that are passed into request. And then when I get the response, I can extract the properties from the HTTP response. One of the things that you see here is that I get the grid information. And then you can see that I do a simple transformation of the data that was passed back. Now keep your eye on grid ID, grid X, and grid Y. I can then use those results from my original request to construct a new resource path to make some additional requests for my forecast and hourly fields. These are going to be resolved in one request handling at the GraphQL API level. When I take a look at what is going on in X-Ray, I made a single request, and you can see that at the top there's query.getWeather. This is the first request that was made by AppSync. But then to resolve the rest of the fields, it does 2 requests in parallel. And it does all this before returning data to your client. So something that would have typically taken 3 or more requests from your client can be done in a BFF in a single request. That's part of the power of AppSync and implementing AppSync in terms of REST APIs. I talked about the fact that AppSync enhances REST, but it also enhances data APIs. One of the powers that we have in AppSync today is that you can use it to interact with things like Amazon Aurora serverless and Amazon Aurora that uses the data API. You don't need to learn anything new to do this. To interact with your Aurora database, simply write some SQL. In our JavaScript resolvers, we give you the utilities that you can use to write simple SQL. Here, we have a template string function that allows you to just write your SQL and pass your own parameters. And this is safe because when we see these parameters, we are simply going to create a query string with placeholders, and we are going to send those parameters in the placeholders. A lot safer than doing it manually or than doing it from your client. We also support interacting with DynamoDB. I think this has been one of the features that we've had for the longest time. AppSync and DynamoDB go great together. It is one of the simplest ways of interacting with your DynamoDB table. We also provide utilities to help you do things like queries, updates, and mutations. So you don't really have to learn any of the maybe convoluted syntax that DynamoDB proposes. You can just use our utilities. And then doing something like an update here with a condition and an increment of a field, something that is pretty gnarly to do with like the regular DynamoDB syntax, can be done really easily in simple JavaScript. And then you can use our pipeline resolvers. Pipeline resolvers allows you to call multiple data sources in sequence without introducing any need for additional compute. So with my GraphQL API, I can call my pipeline resolver, I can make a call to my DynamoDB function, and then I can use the result from that query to build another query for my Aurora database. So a very simple example here. I have my pipeline function. The first thing that I do is that I go to a DynamoDB table and I say, get me an item with the key given the ID that I supply from my arguments. I get the result, and then in my second function that is executed in sequence, I can simply use the result from whatever I got from DynamoDB to build a SQL query. So it may be that I'm using a DynamoDB table because it works best for fetching a single item, but then to do queries, arbitrary queries, I may want to use an Aurora database. And that's fine. I can mix and match my data sources, and it works great within AppSync. So this is AppSync GraphQL. Enhances APIs and enhances REST, enhances data sources. But to really show you some of the powers and what it can do for you, I'm going to hand it over to Michael to dive into the first demo.
Perfect, thanks Brice. So I think Brice touched on a couple important pieces here. When it comes to AppSync, the real power comes with the direct integrations that it has. You saw Aurora, DynamoDB, there's EventBridge, Lambda, etc. What I'm going to show you in this example is sort of the hello world. All of those slides essentially in the fact that they brought everybody up to speed on what AppSync is. The hello world version of that is a chat app. You get all of your CRUD operations, plus you get real-time WebSocket support. So we're going to dive in here. As you can see, this is my beautiful chat application. And I'm going to go ahead and get started. Now, AppSync ties in not just on the back-end side of things with direct integrations, but also on the front end. So Amazon Cognito, perfect use case for tying in with AppSync. So you have this sort of two-way ecosystem of services working together here. Let's get an email set up. And I think that's my password. Cool. So as of right now, I'm set into my chat application. I need to create a room. AppSync is going to talk directly to DynamoDB to get that room created. We can call this like cool reinvent people. There we go. Room is created. I'm taken to this URL, and then down here, I'm super zoomed in right now, but down here I can type in a message and get things started. A couple of things are going to be happening here. As I type this in, this is the real deployed chat application. If you visit the URL, you can chat with me, but we'll get to that later. As of right now, if I type in a message, I can say hello. This gets sent off. It's persisted, so if I refresh the page, sure enough, the message is going to pop right back up. Cool. In addition to having simple text on here, I can also store things like an S3 image ID. A lot of folks ask me, Michael, how do I tie in S3 with my API? Simple enough, you just take the S3 key, attach it on your API for AppSync, and then you can reference that. So I have a pretty cool image here. What do I have? A couple cool kids right up here. Awesome. Let's bring that one in. And with a strong enough internet connection, we can get this image sent over. So I'm going to send that off. There we go. And so far what we have is AppSync talking to DynamoDB, and all those real-time connections are coming back into my application. And again, if you were to visit this URL, we'd be chatting together. And with one API, you have create, read, update, delete, in addition to real-time WebSocket endpoints. This is like the least interactive demo that I have, and it's just the hello world to get us off the ground. But again, a chat app is typically where you get started when you're working with AppSync. I'm going to hand it back over to Brees.
Yeah, what I love about this is that it's so easy to set this up. Like what would typically require a whole bunch of infrastructure to set up, AppSync, DynamoDB, S3, and there you go, you've got it set up. Okay, I'm going to go back to the slides now. And I am going to move to the next section, and I'm going to talk about real-time experiences with AppSync Events. Now, most folks here have said that they used AppSync, and you've probably used AppSync to leverage GraphQL. But we've been running AppSync for a while now, and we have a lot of customers that use AppSync for the GraphQL benefits, but a lot of customers that also use AppSync specifically because they want to use AppSync subscriptions. Customers today are using AppSync subscriptions to enable real-time experiences in their APIs. We've got a lot of customers that do this. And there's a very good reason for that, right? Like if you think about a lot of the applications that you interact with today, you're going to find real-time examples all over the place. You know, whether you're a sports fan or you're shopping online or you're in group chats like we just looked at with Michael, real-time experiences exist everywhere. And they exist everywhere because they provide an enhanced experience for customers. When I go to my favorite sports site and I look up for scores, what I don't want to do is stand there and keep on refreshing the page to see what's going on. When I go and I try to bid on an item, same thing. I don't want to have to refresh this page to find out what the latest price update is. Or I don't want to have to refresh the page to find out that something actually ran out of stock. So real-time experiences are actually crucial to modern web apps today. So these are examples that you can see here of event broadcasting. But these things are even more important when you look at collaboration. When you start looking at collaboration where you have multiple users or multiple people working together, like real-time becomes even more important. You want to make sure that you can relay information, pertinent information with very low latency. Like if I am doing a location update, and somebody is working for turn-by-turn information, right? Low latency is super important, and being able to send the pertinent information to the right person is also super important. So we see these real-time experiences all over the place. But enabling real-time is actually kind of difficult, right? A bit earlier, I talked about the fact that if you have a REST API, you can get into this whole polling thing to get your real-time updates. Trust me, it works. I think that's how most of the internet works today. We're doing polling and we're just polling REST APIs all over the place. That's great, but it's really not efficient, right? It's not efficient for the client because it creates a lot of load at the client. Your client is constantly in a loop refreshing data. It's not efficient for your REST endpoint. If you've done this, you probably know that at scale, if you have more than a couple of hundred of applications that are polling your backend, generates a lot of load, right? It's unnecessary resource usage and it doesn't really scale well, right? The other thing is you can use WebSockets to implement this. And WebSockets are great for low latency. The thing is that WebSocket, all it is a semi-pertinent connection. It doesn't really offer you any connection management, right? So if you're trying to broadcast messages to a whole bunch of individuals, how do you track who you've broadcasted to, right? If you're trying to multicast and you need to keep tracks of groups, how do you track who which group you're sending messages to? And how do you deal with auto-scaling? So there's a lot of complexity that actually comes with managing WebSockets. And then the other part of this is that there's just a lot of backend code. No matter what you do, there's going to be a lot of backend code if you implement this by yourself. So the way a lot of time I think about this is, what is the value that doing any of this brings to your own customer, right? Spending a lot of time trying to address these problems actually takes away time of building features that really matter to your end customer. And if we look at the experiences and what is available to build real-time experiences today on AWS, there are a couple of options, right? You could use Amazon API Gateway WebSockets. This is great, it works just fine. You get your managed WebSocket API, but you do have to do the connection management by yourself. You can use IoT Core, great service, but it really works well for IoT devices. You know, if you've got a web and mobile app where you need to use like a different type of authorization mode, that's not like a certificate and that's not an IAM role, sometimes there's a bit of friction there. And it also means that you need to know about MQTT, right? Which means that you need to use an MQTT SDK. And then last but not least, there is AWS AppSync GraphQL. This is awesome. That's my service. I'm biased. But it does require you to know about GraphQL. And in some cases, customers actually don't need the GraphQL part. All they really want is the subscription part. They want that scale in those WebSockets that we manage. Customers have really asked us for purpose-built pub/sub solutions for creating real-time experiences. And what would you know? That's why we came up with AWS AppSync Events, which we think is the easiest way to build and scale real-time experiences. AWS AppSync Events essentially offers you a fully managed pub/sub WebSocket API that you can use to implement real-time experiences in minutes, in seconds actually, I think. It helps you reduce operational overhead, boost your application performance, and it's really easy to get started with at very low cost. AppSync Events is really simple. It's just a WebSocket. You have a publisher that can push data over an HTTP endpoint, and you have your subscribers that can subscribe to channels over WebSockets. And that's it. That's all you need to know about this. There's no special library that you need to use. There's no special implementation. You get all of the benefits of AppSync that you know about today, but all you really need to do is configure a channel and use it. It's that simple. And it's so simple, in fact, that I think I'm going to be quiet for a few minutes here, and I'm going to hand it over to Michael to show us a couple of demos and some of the cool things that you can actually do with AppSync Events.
Okay. I love my job because Brees, as the solutions architect and as the project manager, he gets to come up with these requirements. And he's like, Michael, can you build something cool for us? I'm like, yeah, cool, I could do that. How about we kind of walk through some demos that I have listed on this page here, okay? And I'm going to do one thing really quick. I have a Chrome extension, and I am titling this Chrome extension / this is important, / reinvent / FWM203. And if you, lovely folks in the audience, want to pull out your phones to scan that QR code, you'll see that you'll also need to enter in /reinvent / FWM203. FWM203. Oh my God, it's working.
You look fast.
Okay. So as that's going in, right, I'm going to say it one more time for the folks that didn't get it. Breeze, can you record this? It's /reinvent/FWM203. Okay, so what's happening here? As of right now, we have just AppSync Events. No GraphQL, no API gateway, no anything else. This is just AppSync Events. Because it's built off of WebSockets, this is so cool. Because it's built off of WebSockets, all I did was have the publisher put onto all of your separate applications. The site that you pulled up is living on a completely different domain. And the WebSocket is living inside of a Chrome extension, which is then picking up these events and putting all of these items on the page. So as we talk about sort of your typical polling solutions, that would never work with this, right? You couldn't sit here and poll, have 50 messages pop up, wait half a second, and then poll some more. That's the beauty of AppSync Events. When you come to, I don't know, auction sites, right? It's all fun and games until we get down to the last 5 seconds and everybody's trying to get their final bid in. This is the perfect use case. This is one client receiving a whole bunch of events at the same time. Now, this is just the demo page. This isn't actually the demo. But in case you're wondering, and in case some of you want to pull me aside afterwards and look at the code, we're looking at 20 lines of code to put this together, of AppSync code, right? I still built the Chrome extension, all that good stuff. All right, so we took a look at the simple chat. This is so cool. But other use cases, real-time leaderboards are another use case. We're on a different domain, so the emojis are no longer popping up. But if any of you, let's blow this up a little bit, how do I avoid legal concerns? If any of you have ever played the game 4 in a row, where you had to connect 4 things in a row, you know what we have here, right? I'm going to put in my username. For those of you that don't know me, I go by Focus Otter everywhere online. And I'm going to generate a new game code. Cool? From here, I'm going to start a new game. I'm going to give you a second in case you want to grab that QR code, play along. It's basically going to be me against all of you, which isn't very fair.
Who wants to challenge Michael?
But at the same time, you all have to battle with the person next to you to get your token in before them. Okay, so there's the site, there's a QR code. Let's start the game. And again, there is no API to this. Now, the good and the bad comes along with that, right? If I refresh the page, everybody's gone. But at the same time, I don't need an API. This is a 4 in a row game, right? They're going to be real quick. A couple of things happen here. Because I don't need persistence, I can have a chat application. Thank you for whoever typed hey. And then we can come in here and we can play a game. Now it's waiting on me. So let's kick this thing off. You're all spectating in case you're not playing. Okay, we're going. This is as real time as it gets, right? I am trying to beat you at my own game. I think I won, right? Okay, so this is what happens, right? Now, again, if somebody wants to click on new game, it'll reset the entire board for both of us, see? All that's happening in real time. I could have easily refreshed the page, but again, you see the effect here. This is AppSync Events. This is real-time data without the need for having a dedicated API. I want to say any questions, but you all have your headphones on, so. Reese?
Okay.
Back to you.
I think that was a great demos. Come on, round of applause for those demos, because that was pretty awesome. That was awesome. We're not even done with the presentation yet.
No.
That's pretty cool. I think AppSync Event it's working on this project and delivering this has been an awesome adventure for me and to AppSync team and all of our engineers. It's been pretty awesome. So as you saw, I think one of the things that we really wanted to do with AppSync Event is simplicity and scale, right? When I talk about simplicity, we want people to be able to start with this quickly. You can go to the AppSync console today, go into the console, click one button to create an API. This is an API that you can start interacting with into AppSync console right away, and an API that will scale to support hundreds of thousands of connected users right away. It's super easy to get started. You can publish events to channels via HTTP. and you can subscribe to channels via standard WebSockets. This works at any scales. I'll show you some of our default quotas in a couple of pages, but it's available today, and you can already publish 1 million messages a second without requesting any quota updates. It's available in all of the regions that AppSync is in, that's about 30 regions, and it comes out of the box with custom domains, AWS WAF integration, CloudWatch logs, and CloudWatch metrics. So your integrations with your favorite AWS services is already available. This allows you to reduce operation, right? I kind of talked about this. It's super simple, and you don't have to focus on the details. You can really just focus on your business logic and focus on the things that matters most to your customers. And overall, this allows you to lower costs because you don't have to manage service. And even if you think about getting started, there's a generous free tier. So if you want to just try this out, go ahead and try it out. We give you 250,000 operations per month under free tier. And then after that, it's a dollar per million event API operations. So pretty good. A few more details on how AppSync event APIs work. I talked about the fact that you publish over HTTP and you can subscribe over WebSockets. The main thing that we define in AppSync events is the concept of a namespace. A namespace is a logical resource that defines the capabilities of a channel. So, a way to explain this, let's say I have a namespace called A. The name of the namespace, so A here, becomes the prefix for any channel that is created within that namespace. So channels are ephemeral. You can create them as you need them, right? The thing that stays is the namespace. And so here, for example, I have a channel called /A/ABC/DEF/XYZ. That's a channel path. And you don't have to create that channel path ahead of time. You create it, your clients create it as they need it. And within the namespace, you can configure your publish handlers. So if you want to create a specific custom logic that allows you to transform data as it's being published, you can do that in AppSync. You can create an unsubscribe handler to specify specific authorization rules that you want to apply when clients try to connect. And you can also override your default channel authorization, right? And you can create up to 50 namespaces by default. But again, remember, within a namespace, you can have an indefinite amount of channels that you create. So pretty flexible. If you use AppSync, you know that we support multiple authorization modes, and all of those authorization modes are supported with AppSync Events. Cognito user pool, API keys, AWS Lambda custom authorizers, OpenID Connect, and IAM. These are great because this means that for your specific implementations, you don't have to worry about how you're going to support it. IAM is great if you have publishers that are like hosted in Lambda functions, or if you're going to publish from an EC2 instance, right? API keys are great in development, and Amazon Cognito user pool is great if you want to specifically identify each user as they connect to a WebSocket. Talking about the quotas and the pricing, this is it in a nutshell, right? 1 million outbound messages per second, 10,000 inbound messages per second, and 2,000 new connection created per second, right? These are the default quotas, and these are all adjustable quotas. But we think that this is an ample size just to get started. So I encourage you to take AppSync Events for a ride. Go into the console, try it out, check it out, play with our PubSub editor directly into console. Look at the blogs that we've published. I publish a blog myself. Michael has a couple of blogs. You can easily find them online. Super easy to get started. Give it a try. Okay, I'm going to switch gears now, and I'm going to talk about generative AI, because, you know, it wouldn't really be a presentation if I didn't talk about generative AI. Right? I got to pay the price. But no, more seriously, right, generative AI is everywhere. I think we can't escape it, and there's so much value in generative AIs and LLMs. There really changes the way we actually work. And this is true everywhere, and this is true of our customers, right? Customers are seeing the benefits of generative AI, and they want to get ahead of the opportunity. They really want to start digging in. So they've been asking AWS, well, this is great. I've got all of these LLMs, and I've got these foundational models. How do I get started? What do I use? How do I move quickly? And how do I keep things secure, right? This is why AWS created Amazon Bedrock, which I think has been a huge game changer. Right? It allows you to interact with multiple foundational models. You can test your models. You can work into console. You can use their guardrails. You can customize models. I mean, just a ton of features, right? It is really the best way to interact with models, in my opinion. It's just so much going on there. But that being said, customers are still facing some challenges when they're building apps, right? When you think about connecting applications, you've got to connect something that sits somewhere in, on the web to your models that sits, in your private cloud. And there's some couple of challenges that need to be addressed. The first one is connectivity, right? You want to connect an application to a backend. For that, you need the proper access control, both for the client, but you also need to be able to regulate how you access your models into backend, right? This is really important. You want to be able to decouple your front end from your back end. And one of the things you definitely don't want to do is leak your back-end credentials in your front-end applications, right? You don't want to have to use the credentials that you use to access your generative AI backend in your client, right? And you also want to kind of create an abstraction, right? A decoupling that keeps your models and your prompt separate from your clients. The other thing that a lot of our customers are struggling with is flexible request handling. If you've interacted with large language models, you know that in some cases, models don't take a lot of time to provide responses. But in many cases, they actually take a lot of time to provide responses, right? So there is a need to use APIs that allows you to use synchronous responses and asynchronous requests as well. And more than that, right, you've kind of seen all of these examples with chatbots where chatbots can take a lot of time to respond, and sometimes that doesn't provide the best customer experience because a lot of us just can't stay focused for that long amount of time, right? If something takes more than a few seconds to come back, we tend to just turn to page. So you need to be able to provide progressive updates, to provide immediate feedback, to let your customers know that things are working well. But we kind of talked about this a bit earlier. You don't want to have to rely on polling and unnecessary requests to make this happen. And then the last thing is that you want to be able to provide contextual information about the requester as you make requests or invocations to your models. Who's asking for the data? How do I identify this user? How do I augment my prompt to provide relevant responses to my user? And then the last thing is flexible model evolution. You're going to start with models, but things change so quickly. It's like every other week, every other month, there's a new model. You want to be able to build your API in a way that you can switch out your model and even evolve your prompt without necessarily creating an impact at your client. You want to be able to keep your prompt in your backend in a way that it is not exposed to your client, so that if you need to make any changes to those prompts, you can actually do that and not cause a major outage or impact at your client. So builders need flexible API solution for their generative AI-powered applications. And this is why we think that AWS AppSync as an AI gateway is a great solution for your generative AI backend, specifically your Amazon Bedrock backend. We think it's a great solution because it allows applications to securely converse with Amazon Bedrock. It allows you to provide real-time solution for long-running workloads. This is something that AppSync does really well already. And it allows you to keep control over user models and user access and model access. And you can start leveraging a lot of the great capabilities of GraphQL alongside the capabilities that your models and your LLMs provide. Now, we've already talked about AppSync, and I already had a slide about this, but one of the key things to talk about is that, first of all, we know about the authorization modes that AppSync provides, right? If you're building an application, you're going to need to be able to provide different modes of authorization, and AppSync does that out of the box. So you already have that one separation. Next, AppSync allows you to interact with your Bedrock data sources using a multitude of ways. You can use AppSync today to connect with Bedrock by using an Amazon Bedrock data source. This is something that we introduced just a couple of weeks ago, and I'm going to talk a bit more about that. You can use an AWS Lambda function to act as an orchestrator. So sending requests to your Lambda function, and then your Lambda function interacts with Bedrock, and you can use that to implement long-running invocations. you can use an HTTP endpoint, an HTTP data source. So one of the things that a lot of people may not be aware of is that we have a data source called HTTP data source, and you can use that data source to interact with any AWS service API. We will sign those requests for you. This makes it pretty flexible. You can actually communicate with any AWS service from AWS. So this allows you to decouple your front-end authorization from your back-end authorization. One of the key things to note here is that by doing this, like I said, you decouple things, but you can also set the specific permissions to allow AppSync to interact with Bedrock. So you could set the permissions on your Amazon Bedrock data source that tells it that it's only able to communicate with a specific model, specific guardrails, or specific prompts. So this is pretty powerful and allows you to manage how your API interacts with Bedrock. Another thing that we've seen from a lot of our customers is the fact that they are using AppSync private APIs in support of their AI gateway implementations. We have a lot of enterprise customers that are starting their journey with LLMs and with generative AI today, but do not want to expose any of their solutions to the outside world. They're essentially building internal APIs. And AppSync private APIs allows them to keep all of this private within their VPC. With private APIs, you can you can restrict your APIs to your VPC, making it the right solution for your private deployments. If we dig a little bit more into the invocations, like I said, you can use an HTTP resolver to invoke your Amazon Bedrock model. This is super easy. This is for situations where you know that your response is going to take less than 30 seconds. The newest thing that we have is a direct integration with Bedrock, where you can use a Bedrock runtime data source in AppSync. And this is great for simple integrations from what we call micro invocations, invocations that take less than 10 seconds. And there are specific use cases where this is the right fit. It provides better control, and you can directly interact with the invoke model and converse API. Here's a quick example of what you can do with this now. Here's a schema. I have a schema with a query and an assistant query that essentially allows me to send natural query language requests to my backend models and ask it to convert it into an actual SQL query. What I'm doing here is that when I send my request to my assistant, I tell it to return a SQL result. And you can see the SQL result defined here with a SQL string, a parameter, and explanation. What I like to do is, I like to take my type and map this to an AWS JSON shape. And this is the type of shape that I can use in my invocation in my Converse API. Here's a request that I'm doing in my JavaScript resolver. I'm using our new Converse utility to directly interact with my Bedrock runtime. This is the same type of function that you will see in other AWS SDKs. So if you've interacted with the Converse API from the JavaScript SDK or Python SDK, it's the exact same thing. I'm using Haiku 3.5. I send my message, I specify the tool configuration, and then I specify the system that it's a database assistant, and based on whether or not I've asked it to explain the answer, I tell it either explain your answer or do not explain your answer. When you interact with LLMs, you have to be super specific. So what's the result? If I send this request, this is what I get. Here's an example. I want to know, what are the most sold items shipped to the city of Las Vegas? Please explain your answer. Because of the way that I was able to interact with the Converse API and specify the shape, I get a result in the exact same shape that I requested it in. I think this is pretty cool, right? Structured output makes my life easier when I'm building a backend API. I can also use the invoke model API to interact with something like Amazon Titan. I can do that to do summarization. I can create embeddings in the same way with the invoke model API. Embeddings are great because once I've got that embedding, I can use that embedding to do a similarity search in my Amazon Aurora database, right? We talked about the fact that we can easily interact with Amazon Aurora, and I can do that here to do a similarity search with an embedding that I've created from a request to Amazon Bedrock. Last but not least, this is the asynchronous pattern. So this is how you create long-running invocations using AppSync. You have a client that makes a request to AppSync. AppSync sends an asynchronous invocation to a Lambda function. Now keep in mind, this can be a Lambda function, but it could also be something like step functions, right? And then this Lambda function then interacts with the Stream API on Bedrock. And as the Stream API on Bedrock returns progressive updates, the Lambda function can then send mutations to your clients via AppSync that will trigger those subscriptions. So now, just by using the AppSync API, I can get real-time update for my long-running queries that are running on Bedrock. This is a key pattern. You're probably going to go to a lot of sessions at reInvent, and you're going to see some of these patterns being used with AppSync. But it is a key pattern because it's enabling a lot of our customers to implement real-time notification and real-time patterns for long-running queries using Bedrock. Okay, so we've got more demos, so let me hand it over to Michael to kind of show us how this works in real life.
Okay. So you saw with the emoji thrower application, that's what I call it, by the way, the emoji thrower application, where you had to specify the channel ID, right? I had to specify it, you had to specify it. Now that we're in sync, we can send messages back and forth. Super cool. And again, I can change that to /reinvent/ some other session, and you can publish messages there as well, so long as that you subscribe to that as well. But as Brice was saying, when it comes to long-running tasks and moving over to Gen AI, because this is where we are nowadays, how do we get information back into our application? We have a direct integration with Bedrock. I'm going to show you that in just a second. But we also have simple use cases that shouldn't be that hard, in all honesty. Right? I have an application. I want to throw an image in an S3 bucket, run some generative AI task on it. Great, I can use a Lambda function for that, right? How do I get that result back into my app? That's surprisingly tricky when you need to have real-time data and it takes longer than a 15-second or a 30-second timeout. How do we do that with an event API? Well, I have a demo for that. Introducing this groundbreaking startup. It's called SnapScribe. Very simple. It allows you to come over here. There we go. Sign into the application. And once you signed in, then you can upload a photo, and it's going to do exactly what that architecture diagram just did. Right? I can browse for a photo. What I'm going to do is grab that same architecture that I just showed you. And again, with the help of the demo deities, great, message received. This is coming from my Lambda function. That's the first AppSync event. And then once it gets done processing, we should be getting an update here any second. I'll just keep pausing my sentences. And there we go. Okay, cool. Let's zoom in and let's take a look, right? Sure enough, image depicts the architecture diagram, yada, yada, yada. I'll let you read that. But this is really cool, right? Because I have a Lambda function being able to do some generative AI tasks, and I don't really care how long it takes because eventually it's going to run that back into my application. My front-end application is just listening instead of polling. That is SnapScribe, but it gets better, right? Because this is a long-running task example. And in case you want to look at the code, as Brice was saying, it really isn't that tough. This is my code that I used to create the application. This is the role, right? You have to define the role that it needs. Essentially, we have Claude doing a lot of the work here with cross-region inference, pretty cool. And then in terms of attaching that data source, I can just drop down to CDK, level 1 construct, say, hey, here's my AppSync API. Here is the Amazon Bedrock runtime. That's the key part here. And then I'm associating that with a new data source, passing in the ARN for the role. Awesome. It doesn't have to be tricky, and it's unfortunate that it was in the past. Now, here's the demo where I need your help, okay? So let's go back here. Because again, that was a long-running task. That could have taken 15 minutes or whatever. What about short-running tasks where we need it within that 10-second window? If you don't mind, one last QR code. This is the final demo. The thing about this application is that it is going to have you sign up. So I'm just going to steadily talk while you get through Cognito and get the confirmation code and all that good stuff. I promise you it's worth it. But as you guys are doing that, again, I appreciate it. Talk about what's happening here. We have a chat app, right? We're coming full circle. In the first chat app, you couldn't take part in it because it really wasn't that cool. This is a lot cooler. As you type a message in here, I'm just going to start typing. I speak English, right? I speak English and I speak Spanish. Those are my two languages that I know. Unfortunately, well, fortunately, in the world that we live in, we have like beautiful languages all over, right? What I'm going to do is I'm going to say, hello, everyone. Welcome to reInvent. And I'm going to hit enter here. So I have this. You notice it's not popping up right away. Super quick, but not immediate. And the reason why it wasn't immediate was because I'm using a pipeline resolver to have AppSync talk to a Bedrock data source. That data source then talks to DynamoDB to place the message inside of the database. Oh, thank you, Nalish. OK, so we have this in place, right? But again, I don't know all of you, and some of you might be more familiar in different languages. So I can say, you know what? Down here, I could switch that. And if you speak Spanish, we can talk in Spanish, right? Hola, mis amigos. And I'm still setting this default language up here to English, right? So we have that in place. I'm somewhere down here. There we go. And I can translate this. So there we go. Everybody's saying hola. Great. ¿Cómo estás? But you know what? We also have simplified Mandarin. Great. We can go down to Italian. And then here's the moment of truth. I can put in whatever language you put in so that we have that as well. Great, great. Awesome. So a couple of things are happening here. As I mentioned, this is a quick ready task, right? We're doing a couple of different things. It's authorized with Cognito. You had to sign in. AppSync ties in directly with that. Great. We also have translations going on. Every time you send a message, it's going to pause to create those translations. Cool. That message gets stored. But using another direct integration with Bedrock, I can come over here and summarize the conversation. This is scary. I've never done this part before. And it's going to take all of these messages. And there we go. Essentially, it's just saying, hey, here's everybody. And we're all present at reInvent. reInvent is a test. And that's the power of Bedrock, right? In case you're wondering what that code looks like, it's super complex, but that's OK. And by complex, I mean like this is the summary code, right? It's 15 lines. And I'm basically just saying, take the chat conversation, 100 words or less, and tell me what you see. Summarize it for me. It doesn't have to be complicated. And again, a lot of that is because AppSync Events just makes it that much easier these days. One thing to note, this is just in my own testing, just quick little asterisks here. Super important to use the right model for the job. A lot of us use our good friends over at Anthropic in their models because they do everything. But in this case, as you saw, I'm using Titan Image. Probably the best model that I've used so far when it comes to summarization, specifically because it was trained on that. But there's the application, right? AppSync for the win. Thank you all. Love the comments. No, please, Falcon, no. There isn't a profanity filter on here.
but you know what? The great thing here is that you can use guardrail to guard against that. That's one of the things that I actually love is that with our integration in your resolver, you can have a guardrail config, and it will actually take care of a lot of that profanity. So not in this demo, but in real life when you implement it, use guardrail configs as well.
Awesome. So as you saw, we had like 6 demos, right? Real time, AI, long running tasks, short running tasks, AppSync GraphQL, AppSync without GraphQL, right? Tons of options here, and it's just one service that really enables a bunch of developers. Hopefully, not to take us to the conclusion too soon, but hopefully you're getting to those moments where you're like, I didn't realize AppSync could do that.
Yeah.
Switch it back over to you, Breeze.
Exactly right. We're almost done. Want to cover one last thing quickly before we go? Okay, I thought I broke this. I mentioned that I wanted to talk a little bit about the security and operations aspect. Like AppSync GraphQL, AppSync Events, and AppSync as an AI gateway are great features, right? But we provide these great capabilities, and customers are able to deploy those great capabilities because of the enhanced security and operational features that we provide. And I think it's important to keep that in mind, right? Like if you're starting to think about AppSync and evaluating AppSync for your own application or for your own enterprise, right? One of the things to know is that AppSync is really built with security in mind. We provide a ton of great features and for security, and you saw that into multiple authorization modes that we provide. You saw that in the way we interact with data sources, the fact that you can create permissions to either grant or reject access or limit permissions, right? These are things that we keep in mind when we implement the service. We have private API support, cross-account capabilities, and merged API, right? Really, it's the easiest way to get started with a lot of features that you need to grow your applications, to share your application with multiple developers, and to take your application to production. One of the important features that we provide actually is merged API. And if you look again at this quote from Gartner, Gartner says that by 2027, 30% of enterprises using GraphQL will use GraphQL Federation, up from less than 5% in 2024, right? So what is GraphQL Federation? Well, GraphQL Federation really embodies this concept of using or bringing together multiple GraphQL APIs under a single API gateway. This is something that enterprises really like, because when you use Federation, it allows multiple teams to own different parts of a database, of a GraphQL schema, without having to step on each other's toes, right? Each team can own their own API and own schema, and those schemas are brought together to create one unique AI gateway that you can take, one unique API gateway that you can take to production. Our solution for federation is actually merged APIs, right? And with our merged API feature, this allows you to combine a group of AppSync GraphQL APIs that are owned by different teams in different accounts and bring them together under a single GraphQL API. This is great to enable cross-team collaboration. Like I said, it also allows your teams to operate independently. GraphQL merged APIs is really simple. You can have your own schema, go into the console or use our APIs to create a merge. We let you know if the merge is successful. We let you know if the merge fails. We let you know if there are conflicts, and you can use a lot of our directives to resolve those errors. So if you have a team and you have concerns about using a single API because your API is growing to be very large and it's connecting to multiple data sources, take a look at Merged API and see how its federation approach can allow you to solve your business problems as well. One of the last features that I want to talk about is private APIs, a feature that is used heavily by a lot of our enterprise customers that have privacy in mind and that want to keep their APIs private. One of the features that was heavily requested for a long time was cross-account private APIs. Customers wanted to be able to create their APIs in a central account and share those APIs across multiple accounts. And so we released this feature maybe a week or two before reInvent, and it uses AWS Resource Access Manager. So uses the standard AWS way of doing things to let you share your APIs that are created in one account with another account. So the typical use case for this is you may have an organization that has a central API or a central account, a central networking account. So all APIs must be created from within that central networking account for auditing or security reasons. Now you can actually do that with AppSync. You can create all of your AppSync APIs in a single account, and you can share them with application accounts. And this is all done using Resource Access Manager and using Private Link. So we're not introducing any additional features. You can use features that you probably already use today to make this happen. And last but not least, we have a lot of folks that are really interested in event-driven architecture. And the good thing here is that we support event-driven architecture out of the box in a lot of different ways, right? You can use AppSync as part of an EDA, event-driven architecture, where the backend talks to the front end with subscriptions. So for example, here I have an EC2 instance that publishes the message to EventBridge, and we have an AppSync target in EventBridge. It sends it to AppSync. Can do the same thing from front end to back end, and you can do also a synchronous front end to back end with subscriptions, which we looked at with models and Amazon Bedrock. Okay, I am right at the end, like it says 0 here. So I'm literally done. But I hope you found this presentation insightful and interesting. I thought we had pretty good demos. If you want to talk to us, we're going to be here for a few minutes, but I really want to thank you for attending the session, and it was great talking to everybody today. Thank you.